Hey everyone, welcome to this AP Physics Explainer, where we're going to tackle a concept that seems super simple, but honestly, it trips up so many students. We're talking about what really happens to an object after you push it.
Okay, so picture this. You're at the bowling alley, right? You wind up, you release the ball, and it just glides down the lane towards the pins. Now here's the question I want you to really think about. What is keeping that ball moving forward after it's left your hand? Seriously, take a second. What's your gut instinct?
So if you're like pretty much everyone else, your brain probably jumped to something like this. Well, the force of my push is in the ball now, right? It's carrying that force with it. It feels right, doesn't it? It sounds so logical. And it's also 100% wrong.
And that right there is why this is such a classic trap in physics. Our everyday gut feelings, what we think should happen, often just doesn't line up with how the universe actually works. But don't worry, stick with me, because we're going to clear this all up. Let's break it down. All right, to get to the right answer, we actually have to go way back, like a few centuries back, to one of the giants of science, Sir Isaac Newton. He's the guy who cracked this exact puzzle with this incredibly powerful yet simple idea called inertia.
So check this out. Before Newton, people believed in this thing called impetus. That's the idea on the left. It's basically the thought that you kind of impart a force into an object, like you're filling up its gas tank, and it just keeps going until that force gas runs out. But Newton, he completely flipped that on its head. He said, no, motion is natural. An object doesn't need a force to keep it moving.
So what is inertia then? Well, the formal definition is right here. It's the natural tendency of an object to resist a change in its state of motion. But honestly, the easiest way to think about it, it's just laziness. Seriously, objects are lazy. They want to keep doing whatever it is they're already doing. If an object is sitting still, it wants to stay still. If it's moving, it wants to keep moving in a straight line at the same speed. It resists change.
Now this next part is maybe the most important thing to get right. We have to be super clear about what inertia is not. And this is the big one. It is not a force. I'll say it again. Inertia is not a force. It's not some invisible engine pushing things along. It's not a battery that runs down. It doesn't cause anything. It's just a property that all matter has, like mass or volume. It's built-in resistance to changing what it's doing.
And this whole idea is wrapped up perfectly in Newton's first law of motion. You'll also hear it called the law of inertia. Think of it as the official rule book for how things move. It sets an object in motion stays in motion, unless acted upon by an unbalanced force. And that last part, unbalanced force, that is the absolute game changer.
Okay, so now that we have this amazing tool from Newton, let's go back to the bowling alley. Let's look at that bowling ball again and figure out what's really going on.
Let's break the ball's journey into 3 parts. Step 1, the push. While your hand is touching the ball, you're applying a force, right? And that makes the ball accelerate. Simple enough? Step 2, the release. This is the magic moment. The instant your hand is no longer touching the ball, that pushing force you were applying, it's gone. It drops to 0. Poof. So what about step 3, the glide? The ball is moving forward, but why? Not because of some leftover push. It's moving forward because of its own inertia. It just wants to keep doing what it was already doing.
Okay, so if the push is gone, does that mean there are no forces on the ball as it glides? Well, no, not quite. There are still a couple of horizontal forces at play. You've got friction between the ball and the lane, and a little bit of air resistance. But notice something? Both of those forces are pushing backwards. They're opposing the motion. And since there's no forward force anymore, those backward forces are, you guessed it, unbalanced. These are the forces Newton's law was talking about, and they're the reason the ball eventually slows down and stops.
So let's just put a pin in this, because this is the whole thing, the big aha moment. The push is what starts the motion. It's the force that changes the ball from being at rest to being in motion. But inertia is the property that maintains that motion after your hand is gone. A force doesn't get stored inside an object and travel with it. It just doesn't work that way.
And look, getting this concept right isn't just about passing one question on a test. This is literally the foundation for almost everything else in mechanics. So let's really lock in the key takeaways here.
All right, if you're studying for that AP exam, screenshot this, write it down, whatever you need to do. This is your cheat sheet. Point 1, motion does not need a constant force to keep going. That's inertia's job. Point 2, forces are what change motion. They cause acceleration. And finally, if all the forces balance out, meaning there's no net force, then there's no acceleration. The object just keeps cruising along at a constant speed.
So I want to leave you with one final little thought puzzle. Imagine you're an astronaut, okay? You're floating out in deep space where there's no gravity, no up, no down. And floating in front of you are two things, a tiny little pebble and a giant, massive boulder. Now, in this totally weightless environment, which one is harder to push? And the real kicker is, why? I'll give you a hint. The answer has everything to do with inertia, and it's the perfect setup for where we go next with Newton's second law. Something to think about.